Hello there, and welcome back to Sleep Lab Science Chanel tonight. Let your shoulders relax, let your breath soften, and allow your mind to drift with me into a quiet corner of the universe, a place where light moves slowly, time breathes deeply, and gravity folds space like warm fabric. Tonight, we wander into the serene, misunderstood realm of black holes. Not as monsters, not as cosmic threats, but as silent, patient sculptures carved by gravity itself. When most people imagine a black hole, they picture a swirling cosmic vacuum, a celestial drain pulling in everything with violent hunger. But this is a story woven from fear and misunderstanding, a story shaped by dramatic movies and anxious metaphors. The truth is far calmer, softer, and infinitely more elegant. A black hole is not a mouth. It does not suck. It does not chase. It simply exists. A black hole is a place where space-time, the invisible fabric that holds the universe together, curves so deeply that it forms a perfect well. Imagine placing a heavy marble on a stretched cloth. The cloth dips gently beneath it, forming a slope. That dip is gravity. And if you add more mass, the dip becomes deeper and deeper, until it's no longer a dip at all, but a bottomless well carved into the fabric of existence. That bottomless well is a black hole. But here's the part people rarely talk about. Nothing in a black hole pulls. Everything simply follows the curve of space-time. A planet moves around a star not because the star reaches out and tugs at it, but because the star bends the space around it, and the planet simply rolls along that curve. Let that thought settle in you. Gravity is not a force pulling downward. Gravity is the path carved by mass. And you, the Earth, the stars, and every photon ever born, you are simply following the quiet, natural curves of the universe. A black hole is the deepest, smoothest, most perfectly carved curve of them all. When a star collapses under its own weight, it squeezes into a space so tiny, so dense, that space-time around it folds like silk under a heavy stone. The curvature deepens until even light, the fastest traveler in existence, cannot find a path that leads outward anymore. And that boundary, that perfect dark shoreline where light loses its escape route, is called the event horizon. But don't picture a wall, or a surface, or anything solid. The event horizon is a moment, not a thing. A threshold of no return for light and matter, yes, but also a place where physics dances in strange, beautiful ways. Before we go deeper, take a slow breath, because in the next chapter, we will sink gently into the meaning of gravity itself, not as a pull, but as a shape, a slope, a gentle folding of space-time. And now, drifting softly, let us slide into Part 2. Part 2, Gravity as a Shape, Not a Force. Let your imagination settle into a soft, pliable sheet, like a blanket stretched across a quiet night. This is space-time. It's everywhere, holding everything, supporting the silent ballet of planets, moons, and stars. Now imagine placing a single pebble onto the blanket. The fabric curves gently around it. That curve is gravity. Not a push, not a pull, but a shape. Einstein understood this before anyone else, that gravity is not something objects feel, but something they follow. A falling object is not pulled down, it is sliding along the natural curve beneath it. A planet orbiting a star is not held in place by an invisible tether, it is simply following the smooth valley shaped by the star's mass. Close your eyes for a moment and imagine Earth orbiting the Sunday. It is not forced. It is flowing, gliding, riding the gentle curvature like a marble rolling around the edge of a bowl. This idea becomes breathtaking when we apply it to black holes. As mass increases, the slope deepens. With a small mass, space-time curves like a shallow indentation. With a star, the curve becomes steep. But with a black hole, the curve drops away so sharply that at the very center, the singularity, the slope is infinitely deep, infinitely narrow, and beyond our current understanding. But here is where the beauty lies. The event horizon is not the steepest point. It is simply the boundary beyond which the curve is so severe that every possible path leads inward. Inside the horizon, down becomes inward, and forward becomes deeper. Even time changes direction, flowing inward the way rivers run downhill. If you were to fall toward a black hole gently, effortlessly, space-time itself would carry you in, like a leaf drifting into a whirlpool. But from the outside, observers would never see you cross the event horizon. Time stretches, movements slow. Your image dissolves into a faint glow, fading like an ember in cooling ash. This is not because black holes destroy time, but because they twist it. They stretch it thin. They allow it to flow differently for different observers. In this way, black holes are not violent. They are patient. They are the masters of time. And as we glide through this understanding of gravity as shape, not force, we approach the threshold of the most misunderstood boundary in the cosmos, the event horizon, a place both simple and profound, a place that marks the transition between the visible and the unknowable. Breathe softly, and let us drift into Part 3. Part 3. Event Horizon, the calm boundary. The event horizon is a story told wrong for generations. Film directors portray it as a raging whirlpool, a cosmic shredder, a place where matter spirals violently into oblivion. But the true event horizon is not chaotic. It is one of the calmest, smoothest surfaces in the universe. A seamless threshold where nothing unusual happens locally, but everything unusual happens globally. Imagine drifting downward in an elevator so smooth that you don't feel yourself moving. That is what crossing an event horizon is like. From your perspective, nothing changes. No flash, no crushing force, no sense of falling. You simply float inward, peacefully, quietly, as if drifting through a doorway made of warm air. But to an outside observer, your final moments before crossing stretch out like honey poured onto a cold plate. Your movements slow, your light reddens, your form smears into a gentle, fading glow until you appear frozen, suspended just above the horizon forever. Two truths coexisting. Inside, falling feels serene. Outside, falling looks eternal. This duality is what makes event horizons so mesmerizing. They bend time differently for everyone. They turn the universe into a set of overlapping realities, each true from its own perspective. The event horizon itself is not a surface. It is a moment where the outward paths for light fold inward. Photons, tiny packets of light, run in every possible direction, but each direction leads deeper into the curve. No direction leads outward anymore. It is the perfect, quiet boundary where escape becomes mathematically impossible. Inside, all paths lead inward. Outside, paths bend but remain free. The horizon is the divide between these two geometries. As you drift closer, imagine slowly, calmly, you would see light curve around you, forming shimmering arcs. You would see stars distort. The universe behind you would stretch like taffy pulled in slow motion. And ahead, the blackness would deepen into a perfect, velvety circle. This is not terror. This is beauty. A silent edge, where the universe folds into its most elegant curve. And as we cross this threshold together softly, gently, we leave behind the surface-level wonders and step into deeper mysteries, where light bends into halos, where shadows become sculptures, and where the cosmos paints with gravity itself. In the next part of our journey, we will explore gravitational lensing, the cosmic art created by black holes as they bend starlight like liquid. But that comes in Part 4. Part 4, the Great Branching. How life diversified into endless forms. The story of life, once begun, did not unfold in a straight line. It didn't march forward like a parade, or grow upward like a single towering tree. Instead, it branched, softly, subtly, like frost crystals spreading across a window pane, creating patterns both delicate and infinite. As we drift into this chapter, imagine Earth around 3.5 billion years ago. The world is still young, its oceans warm and heavy with minerals, its continents still forming, the skies glow with a soft bronze tint. And everywhere from deep-sea vents to shallow coastal pools, life is settling into its new home. The earliest organisms are simple, but they are patient innovators. They explore different forms of metabolism, tasting energy in many ways. Some feed on chemical gradients near volcanic vents. Some absorb sunlight, like tiny biological panels. Others learn to break apart molecules in the water and atmosphere. Each experiment alters the environment, and each environmental change creates new opportunities. This is the quiet dance between life and Earth, a feedback loop that will continue for billions of years. Soon, these organisms begin to specialize. Some grow protective walls. Some develop complex membranes. Some form colonies that function like cooperative villages. Some learn to store energy more effectively. Some discover symbiosis partnerships that benefit both sides. One of these partnerships is so powerful it becomes the foundation of all complex life. A merger between two simple cells that gives rise to the first eukaryotes, ancestors of plants, animals, fungi, and everything else we might one day see with our eyes. And so, life branches again. These new cells are larger, more flexible, capable of housing multiple internal structures. They can eat other cells, build tissues, and store information more efficiently. Over millions of years, they experiment with new shapes, new behaviors, new possibilities. Some flatten into leaf-like sheets, some round into soft, floating spheres. Some grow tails that let them swim in quiet spirals. Some form filaments that link into early colonial organisms. Everything is slow, gentle, gradual. Evolution is not urgent. It moves like a tide. We often imagine life diversifying quickly, dramatically, explosively, but the truth is more tranquil. Most changes drift into existence over countless generations, almost imperceptible. Yet with enough time, these small shifts accumulate into a planet filled with astonishing variety. By 800 million years ago, Earth is covered with a soft, shimmering biological film. Tiny plankton drift through oceans. Primitive algae spread in shallow waters. Microbial mats cover rocks like living tapestries. Oxygen levels rise. Ice ages sweep through and recede. Tectonic plates drift, mountains rise, seas deepen. With each planetary transformation, life branches further. It adapts, reflects, responds, evolves. And then after billions of years of this quiet experimentation, something extraordinary happens. A dramatic burst of diversification unfolds across the seas. The Cambrian explosion. New body plans appear. New senses. New ways of moving, hunting, feeding. But that is a story for another part. For now, let us drift gently along this branching tree of life, toward the moment when complexity bursts into view like a sunrise across the oceans. Softly, we transition into Part V, Part 5, the Cambrian Seas. When life opened its eyes, let us now descend into the oceans of 540 million years ago, oceans alive, with soft blues and flickering sunlight. Oceans where the most dramatic transformation in biological history is quietly beginning. For billions of years before this moment, life has been mostly microscopic, but as oxygen levels rise and ecological niches expand, organisms begin experimenting with something new. Bodies with symmetry, limbs, exoskeletons, senses, and the first primitive nervous systems. Picture yourself floating weightlessly through those seas. The water is warm, shallow, and crystal clear. Beneath you lies a sandy seabed sprinkled with algae and microbial mats. Around you drift creatures unlike anything alive today, soft-bodied forms that resemble folded ribbons, segmented worms gliding through silt, early sponges filtering the water in slow, rhythmic pulses. And then, with quiet confidence, new shapes appear. There are trilobites, small, armored explorers scuttling across the seabed, their compound eyes gleaming like tiny crystals. There are anomalocaridids, swift swimmers with rippling flaps and circular mouths lined with teeth. There are opabiniids, peculiar five-eyed organisms with long, flexible proboscises. There are early chordates, faint ancestors of fish, their translucent bodies shimmering with muscle bands. The Cambrian seas are not chaotic or violent, though competition is rising. Instead, they feel like a curious workshop, a creative space where evolution experiments with endless blueprints. Eyes evolve in multiple groups, legs appear in several forms, skeletons emerge, shells harden, senses sharpen, movement becomes more dynamic, predation begins, but softly, slowly, shaping the arms race of life with each passing generation. One might think such rapid diversification would feel loud, explosive. But here, it feels more like a bloom, like watching a field of flowers open all at once, petals unfolding in silence beneath the dawn. As ecosystems grow more complex, food webs expand. Suddenly, there are hunters, scavengers, filter feeders, grazers, and burrowers. Each niche feels like a note in an unfolding melody. The seas grow richer, deeper, more colorful. Life continues, refining its designs. External skeletons become stronger. Muscles become more coordinated. Eyes capture more light. Neural pathways organize into early brains. And throughout it all, the ocean keeps breathing, tides rising and falling, waves carrying nutrients, sunlight streaming down in golden shafts. The Cambrian period lasts tens of millions of years, yet in the cosmic timeline, it feels like a moment of inspiration, a flourish added to the long poem of life. As we drift upward toward the surface, we feel the pulse of the Earth changing once again. New continents are shifting, climates oscillate, sea levels rise and fall. Life is moving toward its next grand transition, one that will carry it beyond the water, onto land, where new ecosystems await. Let us drift now toward that gradual, world-shaping journey into Part VI. Part 6. The first steps onto land. When Earth became a living planet, if we float forward in time slowly, like a leaf carried by a gentle current, the scene before us changes. We rise out of the Cambrian seas and enter a world still quiet, still almost empty, but ripe with possibility. The continents of 400 million years ago are barren. No grass, no forests, no animals. Only rock and sand stretch across the landscape, sculpted by wind and rain. The air is rich in carbon dioxide. Temperatures are warm. Rivers and deltas braid across the surface like silvery veins. But along the shorelines, something new begins. Tiny photosynthetic organisms, algae, and primitive microbes cling to damp rocks. They form thin films, early mats, fragile green stains that darken with sunlight. These are the pioneers, the scouts of life, testing the boundaries between sea and land. For millions of years, they remain small, but gradual adaptations accumulate. Some algae develop stronger cell walls. Some tolerate dryness for short periods. Some begin forming simple root-like structures to anchor themselves. The first true plants emerge. They are tiny, moss-like, without leaves, without flowers, but they are determined, persistent, quietly prolific. They spread across wet ground, creating patches of green that slowly expand inward from the coast. As plants spread, they begin shaping the land itself. They retain moisture in soil. Their roots break down rock. Their presence cools the surface. They pump oxygen into the atmosphere. The land begins to breathe. Soon, arthropods follow the plants ashore, early millipedes, scorpions, and later insects. They explore the mossy mats, grazing, hunting, shedding exoskeletons in the young air. The world begins to change color. Greens deepen. Shadows lengthen beneath taller plants. Forests, primitive at first, spread. Oxygen levels soar. Earth is transforming from a silent stone world into a living, breathing ecosystem. Then comes an even more dramatic step: vertebrates. Descendants of lobe-finned fish develop strong, limb-like fins. They push themselves through swampy shallows, moving between pools. Over time, bones strengthen, joints refine, lungs improve. The first tetrapods emerge. Clumsy at first, then more confident. They begin to walk on land, the earliest ancestors of amphibians, reptiles, birds, and mammals. Their footprints mark the sand like soft signatures of evolution. And still, everything remains calm, patient, steady. There is no rush. Nature takes its time, shaping new body plans across tens of millions of years. By the end of this period, around 360 million years ago, Earth is no longer a barren planet. It holds forests, insects, rivers lined with greenery, shallow freshwater ecosystems teeming with early vertebrates. Life has conquered a new realm, not with chaos or force, but with persistence, adaptation, and the quiet power of time. As we drift away from these early landscapes, we feel the world preparing again for another transformation, one involving towering forests, giant insects, and the slow rise of reptiles. Softly now, we continue toward Part 7. Part 7. The Age of Forests. When Earth learned to breathe deeply, let us drift forward again, through millions of years that pass like soft exhalations. The world we now return to around 360 to 300 million years ago is not the barren land we left behind in Part V's. No, it has deepened, darkened, softened, become lush in ways that feel almost dreamlike. This is the Carboniferous, the age when Earth adorns itself with forests so vast and dense that they transform the very chemistry of the air. Imagine stepping slowly, quietly into one of these ancient forests. The canopy stretches high above, but not with the trees we know today. Instead, towering lycophytes rise like living pillars, some more than 30 meters tall. Their trunks are scaled, textured like spiraling patterns carved by time. Seedless ferns tower overhead, unfurling enormous fronds that filter sunlight into gentle emerald shadows. Everything feels humid, soft-edged, muffled by layers of leaves. The air is thick with moisture. The ground yields underfoot, cushioned by mosses and decomposing plant matter. This is a world before flowers, before birdsong, before the broad diversity of modern trees. Yet it is alive with a soft hum, the breath of a planet densely cloaked in vegetation. As forests spread, they inhale carbon dioxide in enormous quantities. Over millions of years, oxygen levels rise to unprecedented heights, nearly 35%, far higher than today's 21%. The air becomes intensely oxygen-rich, like a slow, planet-wide breath drawn in and held. And this abundance of oxygen shapes life in remarkable ways. Insects, dependent on oxygen diffusion for respiration, grow to astonishing sizes. Dragonflies the size of hawks glide through the forest with silent, shimmering wings. Millipedes as long as small cars curl through the underbrush. Giant scorpions scuttle along the moist ground, their claws gleaming softly. But even these oversized creatures do not disrupt the forest's tranquility. Everything moves slowly, carefully. The air is warm, still, and tinged with the faint sweetness of decaying plant matter. The forests shape Earth, and Earth shapes the forests. As trees die and collapse, their wood accumulates in immense layers. Because fungi capable of breaking down lignin, the tough structural molecule in wood, have not yet evolved, the dead trunks pile up untouched. Over millions of years, heat and pressure compress this organic matter into coal, creating the vast coal beds that humans will one day uncover. These forests, in other words, are painting the future. The rise of deep roots stabilizes soils, alters river patterns, and influences sedimentation across entire continents. Plants pump vast amounts of oxygen into the atmosphere, while trapping carbon beneath the earth. The world cools slightly, Rainfall patterns shift. Life adapts. Once again, amphibians, dependent on wetlands, flourish. Their soft bodies and sprawling limbs make them masters of swampy environments. But as forests spread and climates shift, new niches open, niches that will be filled by creatures capable of venturing farther inland, away from water. This transition leads gently into a new lineage, the early amniotes, animals that lay eggs with protective membranes, allowing embryos to develop on land without drying out. From these early amniotes will arise the ancestors of reptiles, mammals, and eventually, all terrestrial vertebrates that wander the modern Earth. But for now, we remain in this dreamy world of towering plants and oversized insects, a world where oxygen hangs thick enough to taste, and the quiet pulse of evolving ecosystems echoes through the green shadows. As we drift slowly through the canopy, we begin to sense the approach of deep change, environmental fluctuations, shifting continents, and more complex ecosystems. And so, with gentle steps, we transition into Part 8, where new kinds of creatures begin to dominate the land. Part 8. The rise of reptiles, architects of the ancient land. From the quiet wetlands of the Carboniferous, we drift into a new chapter 1, shaped by resilience, adaptation, and the growing complexity of life on land. The shift is subtle at first. The climate dries, forests fragment, swamps shrink. Ice advances toward the poles during a long, slow cooling event. Amphibians, once abundant, struggle to survive as habitats change. Their moist skins and dependence on water tether them to vanishing environments. But another lineage, quieter, smaller at first, begins to flourish. These are the early reptiles, descendants of amniotes, who have evolved tough, watertight eggs, dry, scaly skin, and more advanced lungs. These adaptations allow them to move freely across drier landscapes where amphibians cannot follow. They explore deserts, forests, rocky uplands, and open plains. They venture far from water. They bask beneath the sun. They burrow into warm soils. They lay eggs safely away from predators. Slowly, gently, reptiles diversify. Some become swift insect hunters. Some grow into larger herbivores. Some develop armored plates or spines. Some elongate into snake-like forms. The age of reptiles begins not with dramatic domination, but with quiet persistence. Meanwhile, continents drift toward one another, converging into a giant supercontinent known as Pangaea. This enormous landmass stretches from pole to pole, creating vast interior deserts and intense seasonal climates. Reptiles adapt to these new conditions with remarkable flexibility. Over millions of years, their skeletons change, their postures shift, their metabolisms refine. They grow stronger legs, more efficient respiratory systems, and more powerful jaws. And from this slow evolutionary refining emerges a lineage unlike any before. The synapsids, early reptile-like creatures with openings behind their eyes that allow for stronger jaw muscles and different skull structures. Some synapsids are small and agile. Others evolve into large, herbivorous beasts with massive barrel-shaped bodies. Still others become fearsome predators. Dimetrodon, with its distinctive sail-like spine, stalks riverbanks with calm, confident strides. These early synapsids are not dinosaurs, but they are the distant ancestors of mammals. Their bodies begin to show hints of future traits, differentiated teeth, more upright stances, and perhaps even early warm-blooded tendencies. Meanwhile, true reptiles diversify even further. The stage is being set, quietly, slowly, for the great reptilian dynasties of the Mesozoic, but not yet. Earth still has more transformations to undergo. Climate shifts, seas rise and fall. Pangaea's interior oscillates between drought and monsoon. Volcanic activity stirs beneath the crust. Plant life evolves new forms. Each change places new pressures on living organisms, and evolution responds like a slow, patient sculptor. As the Permian period draws to a close, life is rich and varied, but a shadow lies ahead. A great collapse is coming, one that will alter the world more profoundly than any event before or since. But before we approach that turning point, let us drift softly into the next chapter, a world on the brink of change. We move gently now into Part IX. Part 9. The Great Dying. Earth's most silent catastrophe. The world grows warmer. Not suddenly, nothing in this story is sudden, but gradually, like a fever that simmers quietly beneath the surface. Volcanoes gasp to life across the Siberian traps, releasing carbon dioxide and methane into the atmosphere for hundreds of thousands of years. The oceans warm, the skies shimmer with heat, the climate tilts, and life, once abundant and diverse, begins to strain under the mounting pressure. This is the Permian-Triassic extinction event, also known as the Great Dying. It is the most severe extinction in Earth's history, wiping out nearly 90% of marine species and 70% of land species. Yet despite its magnitude, it unfolds with a strange, haunting slowness. Imagine standing beside an ancient shoreline as temperatures creep upward, year by year. Fish struggle in oxygen-poor waters. Corals bleach and crumble. Forests collapse into open, barren landscapes. Insects once thriving in carboniferous abundance decline for the first time. Methane erupts from thawing ocean sediments, accelerating warming. The seas grow acidic. Ecosystems unravel, quietly, like threads slipping from a tapestry. But this is not the end of life, only a reshaping. Some creatures survive by burrowing underground. Some persist in deep ocean refuges. Some adapt to drought and heat. Some develop faster metabolisms or more efficient reproductive strategies. Among the survivors are small, hardy reptiles, and a few resilient synapsids whose descendants will one day become mammals. The extinction clears ecological space vast, empty niches waiting to be filled. And when the climate stabilizes once more, evolution begins its patient work again. Slowly, gently, life returns. Plants recolonize barren ground. Rivers repopulate with fish and crustaceans. Insects evolve new wings and feeding strategies. Reptiles once again diversify, filling the void left by vanished species. And from these survivors, over millions of years, emerges a new lineage, one that will grow into giants, dominate Earth's ecosystems, and shape the next age of the planet. But that is the story of the Mesozoic, the age of dinosaurs, and it awaits us in the next chapter. For now, we float in the stillness after the storm, the quiet pause between eras, as Earth rearranges itself for the arrival of creatures that will someday rule both land and sky. Softly now, we move toward Part X. Part 10, the slow drift of comets and the memory of ancient ice. Imagine, now, that we drift farther outward beyond the familiar orbits of Mars, Jupiter, and even the shimmering frost of Saturn's rings, into the deep, quiet reaches of the solar system, where sunlight thins into a pale whisper. Here, time behaves differently. Distances stretch into something abstract and ghost-like. And moving through this stillness are some of the oldest, coldest travelers ever known. Comets, tiny frozen libraries, holding memories older than Earth itself. A comet begins as a small and silent thing, no larger than a city block, sometimes no larger than a human house, and yet it carries within it a story 4.6 billion years in the making. A mixture of ancient ice, primordial dust, and organic molecules older than our Sun. Comets are fragments left over from the beginning of everything, while planets gathered into orbits, smoothing themselves into worlds. These icy wanderers remained wild and unfinished, drifting at the edges of the newborn system. As we glide beside one, we can imagine its surface, dark as burnt charcoal, speckled with frozen gases, all preserved at temperatures colder than anything the human body could fathom. The nucleus is like a frozen heart, barely glowing, quietly waiting. And yet, with just the smallest touch of warmth from the sun, everything changes. Approach brings awakening. As a comet falls inward, sunlight seeps into the ice, turning solid into vapor, quiet into motion. Jets erupt like sleeping breath. Dust lifts from the surface. Gas stretches outward, and soon the comet grows a glowing coma, a luminous atmosphere that can stretch for tens of thousands of kilometers, surrounding the tiny nucleus like a shimmering cocoon. The tail that follows, so elegant and mist-like, is not a single tail at all, but two. One of gas, silky and blue. One of dust, soft and golden. Both always point away from the sun, pushed gently by solar radiation and the whispering wind that flows from our star. Even though the nucleus itself remains small, its tail can stretch across millions of kilometers, becoming one of the largest structures in the solar system. And through all this motion, the comet remains calm, ancient, unhurried. Its orbit may take hundreds, thousands, or even millions of years to complete. Some visit the inner solar system once in a human lifetime, like Halley, whose 76-year return has been chronicled since antiquity. Others may glide near the sun only once before being flung out again into the darkness. Imagine that one slow, wandering arc through sunlight, and then a return to endless night. Scientists sometimes call comets time capsules, because inside their icy bodies lies chemistry older than Earth's oceans, older than Earth's rocks, older than the Earth itself. Some of these molecules, like amino acids and carbon-rich structures, hint at the origins of life, perhaps carried to early Earth by falling comets. In this sense, they are not only wanderers, but also messengers, delivering ingredients that may have helped spark biology. And as we drift beside them in our dreamlike journey, we can imagine what it feels like to be such a traveler, silent, persistent, circling the sun across unimaginable distances and timescales, holding ancient memory in every grain of dust. The solar system is full of motion, full of brightness, full of drama, but here, with the comets, we feel something different, a gentler rhythm, a reminder that not all things move quickly, and not all things burn with intensity. Some glide in a slow, soft dance, taking thousands of years to pass from cold to warmth and back again. As we release the image of the comet and drift onward, we let its calm trajectory guide us into the next quiet region of our cosmic journey, where icy worlds linger far beyond the outer planets, waiting in the hushed darkness. And so we gently transition to the next part. Part 11. The Kuiper Belt, a frozen neighborhood beyond Neptune. As the comet fades into the distance behind us, we find ourselves at the edge of Neptune's domain, where the last of the major planets casts its ghostly blue light into the surrounding dark. Here begins a region both vast and delicate, like frost, stretching endlessly across a cosmic windowpane, the Kuiper Belt. The Kuiper Belt is not like the asteroid belt we passed earlier. The asteroid belt is warm by comparison, rocky, buzzing with sunlight. But out here, sunlight is faint, only a thin thread, and everything takes on a slower, softer presence. The Kuiper Belt is made of ice worlds, quiet spheres of frozen methane, nitrogen, and water, drifting through the dim outskirts of the solar system, like preserved fragments of early creation. And among these frozen wanderers lies one world you know well, Pluto. Pluto, once called a planet, now known as a dwarf planet, glows gently in the weak sunlight, a tiny world with a big heart. Literally, the famous heart-shaped region of nitrogen ice on its surface, called Tombaugh Regio, has become one of the most iconic features of any distant world. When NASA's New Horizons spacecraft flew past in 2015, it revealed a landscape far more beautiful and varied than anyone expected. Mountains of solid water ice, plains of frozen nitrogen, vast glaciers slowly flowing across the surface in patterns that look like a giant snowfield. And yet, Pluto is not alone. The Kuiper Belt contains thousands of icy bodies. Eris, Haumea, Makemake, each with its own secrets, shapes, colors, and moons. Some are elongated, spinning quickly. Some are reddish, coated with organic compounds. Some are nearly perfectly round. Many have never been visited or even photographed up close. Imagine them, scattered across space like tiny lamps glowing in the half-dark, each moving slowly along orbits that can take hundreds of years to circle the Sunday. The region is so wide that if the solar system were a city, the inner planets would be a small downtown district, while the Kuiper Belt would stretch out across entire provinces, silent, spacious, cold. And yet, this region is not empty of meaning. Scientists believe these icy bodies are leftovers from the solar system's formation, the debris that never clumped into a planet. Their chemistry tells us what the building blocks of planets once were, frozen in time, unchanged for billions of years. Drifting here feels peaceful. There are no bright storms, no blazing rings, no rushing winds, only slow orbits, soft light, and the quiet presence of ancient ice. This is a place where time stretches thin, and as we continue our journey outward, the Kuiper Belt slowly fades behind us. Ahead lies an even more mysterious region, one so distant it exists only in faint mathematical whispers, the place where the comets of the deep begin their endless arcs. Let us drift onward into that final frontier. Part 12. The Oort Cloud. The solar system's whispering edge. Beyond the Kuiper Belt lies a realm so vast it becomes nearly impossible to imagine. It is not a disk like the planets follow, nor a ring like the Kuiper Belt. Instead, it is a spherical shell, surrounding the solar system in every direction, like an invisible bubble stretching halfway to the nearest star. This is the Oort Cloud, the quiet, frozen boundary between our solar system and interstellar space. No spacecraft has ever reached it. No telescope has ever directly seen it. And yet scientists know it must be there, because long-period comets, the ones with orbits lasting millions of years, must come from somewhere. Their strange, sweeping paths cannot be explained by the Kuiper Belt or the planets. They come from far beyond. Imagine an entire vast region filled with icy bodies, perhaps trillions of them each no larger than a mountain, drifting quietly in the deep cold. They are so far apart that if you stood on one, you might not see another for light years. Each is like a tiny seed of frozen material, suspended in a near-perfect silence. These objects are loosely held by the sun's gravity, so loosely, in fact, that passing stars or even the tide of the Milky Way can shift their positions. Every so often, one of these distant icy bodies gets nudged inward, beginning a journey that may last millions of years. And eventually, after an unimaginable amount of time, it may appear in the inner solar system as a bright comet, spending a few months in sunlight before returning to its ancient home. Drifting here, in this hypothetical sphere of ice, feels like floating in a dream. The stars seem sharper. The sun is only a bright point, not much stronger than any other star. The darkness is softer, more velvety. Space itself seems to exhale. The Oort Cloud is not just a boundary, it is a symbol of distance, time, and cosmic memory. It represents the outermost breadth of our solar system. Beyond it, we are no longer within the sun's family. We would be stepping into the realm of the galaxy itself. And yet, even here, in this barely imagined place, there is calm. No storms, no orbiting moons, no glowing atmospheres, only ancient ice, slow movement, long silence. As we drift at the very edge of the sun's influence, we can glance back inward one final time toward the planets, the comets, the Kuiper Belt, the warm inner system, and the brilliant star at the center of it all. The solar system feels like a chain of quiet stories stretching from warmth to cold, from light to darkness, from youth to ancient memory. And with that gentle understanding, our journey continues toward more cosmic tales waiting in the deep. Part 13. The sun's quiet influence and the breath of the solar wind. As we leave the imagined stillness of the Oort Cloud and drift inward again, we slowly begin to sense the soft presence of something that has been with us all along. The sun's distant breath. Even here, at the verge of interstellar space, faint particles from the sun, tiny charged fragments of ancient starlight, still drift outward in a delicate, continuous stream known as the solar wind. The solar wind is gentle out here, barely a whisper, but as we move inward, the whisper becomes a breeze, and the breeze becomes a steady flow, shaping invisible boundaries and crafting protective cocoons around planets. The sun's influence stretches extraordinarily far, forming a vast bubble called the heliosphere, a glowing shield that keeps much of the galaxy's harsh radiation at bay. Traveling through this heliosphere is like passing through an enormous cosmic atmosphere. The further inward we drift, the more familiar the sun's warmth becomes. Not physical warmth, for space remains cold, but a softening of distance, a growing brightness, a quiet reassurance. The solar wind sculpts planetary magnetic fields into long tails, carves auroras into dancing curtains of light, and sweeps dust into wandering streams that stretch across space. It is one of the most subtle forces in the solar system, shaping everything while remaining mostly invisible. And yet, this gentle breath is older than Earth, older than the planets, older than the frozen objects that drift at the solar system's edge. It has been blowing for billions of years, carrying clues to the sun's interior, its rhythms, its moods. As we feel this quiet current carry us inward, it becomes a bridge guiding us toward the next story, where the planets themselves rise into view once more. A bright world emerges first, glowing with oceans of gas and wind stronger than anything on Earth. A giant, a guardian, Jupiter. And so we continue, still drifting, toward the largest world in the solar system. Part 14. Jupiter, the sleeping giant of storms and light. Jupiter appears not gradually, but overwhelmingly, a world so large that it reshapes the space around it. It is a planet with no solid surface, only deepening layers of gas, each more mysterious than the last. Its stripes swirl in slow, hypnotic patterns, as if the planet dreams in color. As we approach, we see storms the size of Earth rising and falling like gentle breaths. The Great Red Spot, that ancient spinning vortex, churns with soft, muted rust tones, rotating in a calm that belies its unimaginable winds. It has been swirling longer than humans have existed, perhaps longer than human ancestors ever took their first steps. Despite its power, Jupiter has a strangely soothing presence. Its clouds behave like a vast, natural painting bands blending together. Storms drifting like slow-moving brushstrokes, flashes of lightning glowing deep within the cloud layers. Thunder here would be silence to human ears, too distant, too submerged in a world with no ground. But Jupiter offers more than beauty. It is a cosmic protector, using its immense gravity to sweep comets, asteroids, and ancient debris into safer paths. Without Jupiter, some scientists believe Earth may have experienced far more catastrophic impacts. The giant's presence is like a silent guardian, watching over the inner worlds. And surrounding Jupiter is a family of moons, each a world of its own. Volcanic Io, icy Europa with its hidden ocean, massive Ganymede with its magnetic field, Callisto with its ancient, cratered face. Together, they drift like a miniature solar system, each whispering a different story. As we slowly pass Jupiter, its colors fading into the distance, we feel the transition again, an invitation to drift further inward, toward a world of rings so delicate they appear like soft cosmic embroidery. A world carved from ice, shadow, and shimmering light. Saturn. Part 15. Saturn and its rings. The solar system's softest symphony. Saturn appears like a dream, pale gold, serene, and surrounded by rings that look almost too delicate to be real. They shimmer like thin layers of mist, stretching far into space. Even though they are enormous in scale, spanning hundreds of thousands of kilometers, they are astonishingly thin, no thicker than the height of a small building. Drifting toward Saturn feels like approaching the quietest symphony ever composed. The rings are made of ice, billions of fragments ranging from grains of dust to pieces the size of mountains. Sunlight sparkles across them, scattering into bright arcs and soft shadows that sweep across the planet's surface. Saturn itself rotates gently, swirling with muted storms. Its pale colors feel calm, like watercolor brushed across a cosmic canvas. Even its storms, though immense, appear softer, their boundaries more blurred, their shapes more dreamlike. And tucked within the rings are tiny shepherd moons, little icy worlds that guide the ring particles, sculpting gaps, waves, and ripples as they drift. Cassini, the spacecraft that once orbited Saturn, saw these ripples up close, waves like those on a quiet lake, frozen in motion. But Saturn offers more than rings. Its moons hold mysteries equal to planets. Enceladus, gleaming white, sends geysers of water vapor into space, evidence of a hidden ocean beneath its icy shell. Titan, Saturn's largest moon, is wrapped in a thick golden haze, with lakes of liquid methane resting quietly on its surface. Together, the rings and moons form a realm of soft brilliance, a place where light behaves differently, where shadows stretch thin, where ice sings in silence. And as we drift beyond Saturn, letting its soft glow fade behind us, we feel the story moving onward. The solar system still has more to show, more to whisper, more to reveal. Soon, we will approach worlds of cold blue winds, tilted axes, and diamond rain. But for now, we rest in the lingering shimmer of Saturn's rings. Part 16: Uranus. The quiet blue dream tilted on its side. Leaving the shimmering rings of Saturn behind, we drift outward once more, carried on a silent current of starlight. Ahead of us, a pale blue marble rises slowly from the dark, a world unlike any other, a planet that seems to rest sideways in space, as if caught in a gentle moment of cosmic repose. Uranus. It rotates on its side, tilted more than 97 degrees, like a giant world quietly reclining. No one is entirely certain how this happened. Perhaps a massive ancient collision nudged it into its unusual pose. Or perhaps the early solar system was once a more chaotic place than we imagine. But whatever the cause, Uranus has become a planet defined by softness. Its colors soft, its storms soft, its seasons long and muted. Up close, the planet is a gentle watercolor sphere of pale aquamarine. Its clouds are faint, almost shy, hiding deep within an atmosphere made of hydrogen, helium, and icy methane. Winds flow silently across its surface, forming patterns too subtle for Earth-based telescopes to see easily. Only when a spacecraft once flew past Voyager 2 did humanity glimpse the planet's serene personality up close. Unlike Jupiter and Saturn, Uranus has no dramatic storms, no swirling belts, no raging tempests. Its calmness is almost eerie, like a lake without ripples. And because it tilts on its side, its poles experience extreme seasons: 40 years of sunlight, followed by 40 years of night. Entire hemispheres fall asleep beneath darkness for decades at a time. Uranus holds a faint ring system too, thin and shadowy, easy to miss unless sunlight glints just right. And its moons, Miranda, Ariel, Umbriel, Titania, Oberon, drift quietly around it, each scarred, cracked, or folded in ways that hint at ancient geological stories. As we drift past Uranus, its soft blue glow slowly fades, but its quietness lingers, like a gentle pause in a long cosmic lullaby. Ahead, another icy world awaits, bluer, windier, more restless, yet still wrapped in dreamlike silence. Neptune is calling. With that soft pull of gravity drawing us onward, we drift to the outermost giant. Part 17: Neptune. Winds, whispers, and the deep blue unknown. Neptune greets us with a deeper, richer shade of blue, a blue so intense it seems to hold the whole night within it. Where Uranus was pale and quiet, Neptune is vivid and dynamic, though still shrouded in a calm that blankets even its wildest storms. This world is the windiest in the solar system, Winds roar across its atmosphere at speeds faster than earthly sound. Yet from here, drifting in the silence of space, it looks peaceful swirls of white methane clouds forming soft spirals across the planet's deep blue surface. The Great Dark Spot, a storm once captured by Voyager 2, appears and disappears, like a shadowy bruise beneath the clouds. It comes and goes unpredictably, almost as if Neptune itself changes moods with centuries-long breaths. And like its siblings, Neptune hosts a family of moons. The largest, Triton, drifts in an odd, backward orbit. Triton is one of the coldest places ever measured, its surface blanketed with nitrogen frost. Yet, beneath that frost, geysers erupt, dark plumes of gas shooting toward the sky before falling back as gentle snow. Some believe Triton might once have been a dwarf planet captured by Neptune's gravity. If so, it now lives a quiet life in orbit, whispering secrets from the icy past of the early solar system. As we drift beyond Neptune, the sunlight grows faint, so faint that shadows no longer look like shadows, and distances begin to blur. Ahead lies a region not quite planet, not quite void, a realm of icy wanderers, a place where time seems to slow with the cold. The realm of Pluto. Part 18. Pluto and the Kuiper Belt. The frozen threshold of the sun's domain. In the soft dimness at the edge of the solar system, Pluto emerges like a small lantern glowing through fog. Once considered the ninth planet, it now rests as one of many worlds in the Kuiper Belt, a vast ring of icy debris circling the sun like a cosmic shoreline. Pluto is tiny, smaller than Earth's moon, yet it possesses surprising landscapes, sweeping nitrogen plains, towering ice mountains, and a heart-shaped region named Tombaugh Regio, which seems to greet every passing spacecraft with gentle affection. As we drift closer, we see that the heart is not just a metaphor, it is a real geological feature, made of frozen nitrogen and smooth, flowing ices that behave almost like slow-motion glaciers. Some parts of Pluto are young, geologically speaking, as if the planet is still reshaping itself quietly in the dark. Its thin atmosphere is delicate, made mostly of nitrogen, and it expands into space when Pluto approaches the sun, then collapses back onto the surface as frost when it drifts away. This cycle is so slow and gentle that entire generations could pass on Earth before anyone saw a noticeable change. Beyond Pluto lies Charon, its large companion moon. The two worlds orbit each other in a gentle, synchronous dance, locked face to face forever. Tidal forces binding their motions into calm symmetry. And beyond them stretches the Kuiper Belt, billions of frozen fragments from the solar system's earliest days. Comets sleep here, waiting for gentle gravitational nudges to send them drifting inward again. Ice, rock, and ancient dust drift in a vast celestial quiet. This region is the threshold, the last whisper of the sun's gravitational cradle before interstellar space begins. As we float here, on the edge of everything we know, the solar system feels like a great cosmic home. And soon, as we drift farther outward, we will leave that home entirely, touching the thin border where the sun's breath fades into the Milky Way's endless night. Part 19. The Oort Cloud. The solar system's sleeping halo. As we drift past the Kuiper Belt's farthest icy fragments, the sun grows so faint it resembles a star among thousands. Shadows blur into the surrounding dark, and distances stretch into a soft, immeasurable silence. Here, we arrive at a realm so vast, so delicate, and so quiet, that no spacecraft has ever touched it. This is the Oort Cloud, the solar system's sleeping halo. It is not a place of planets or moons or rings. Instead, it is a drifting sphere of icy bodies, trillions of them each tiny, compared to worlds we've passed, yet collectively forming a boundary that extends nearly 1 light-year from the Sunday. Imagine floating through a snowy night, where each flake is suspended, still, untouched. That is the feeling of the Oort Cloud. Each icy body here has slept for billions of years, undisturbed, preserved like fossils in a cosmic deep freeze. Many comets begin their journey out here, with tiny nudges perhaps from a passing star, or from the gentle gravity of the Milky Way. They begin slow, long orbits inward, becoming glowing streaks of light when they approach the warmth of the Sunday. These comets, with tails that stretch across the sky, are messengers from a time before Earth was born. But out here in the Oort cloud, they rest, silent, waiting, suspended between the pull of the sun and the tides of the galaxy. The sun's influence is fragile here, fading into the background, blending with the gravity of distant stars. If we looked around, the sun would be little more than a bright pinprick, a reminder of the warm, vibrant worlds we've passed through. Outward from here lies true interstellar space, a place where the solar system's gentle cradle ends and the galaxy's wide ocean begins. Yet before we drift past this boundary, the Oort cloud offers a final moment of stillness, a breath of peace at the edge of our cosmic home. And as this breath fades, we begin to float even farther, letting the solar system shrink behind us, becoming a faint lantern surrounded by endless night. Soon, we will look back on it from afar, seeing the entire system as a single shimmering memory. Part 20. The solar system from afar, a soft farewell. Drifting beyond the Oort cloud, the sun becomes simply one star among many. Its planets, moons, rings, belts, and drifting particles blur into invisibility. With enough distance, the solar system folds into a single shimmering point, a warm light, glowing quietly in a vast expanse of darkness. From here, the planets we know so well become invisible threads. The gas giants no longer appear as swirling tapestries. Earth no longer shows continents or oceans. Pluto no longer clings to the edge of its elliptical path. Everything merges into the faint glow of the Sunday. It is peaceful to see our home like this, small, gentle, unified. A single light, floating in the ocean of the Milky Way. The solar system drifts through the galaxy as part of a slow, graceful orbit, taking hundreds of millions of years to circle the galactic center. Along the way, it passes through clouds of interstellar gas, regions of denser star fields, and lanes of dark dust. Yet from out here, these movements feel like soft, gradual breaths, cosmic rhythms too slow to perceive, too vast to disturb the quiet. Looking back, we also remember how each world contributed its own note to the solar system's lullaby. The gentle pull of the sun, the swirling brilliance of Jupiter, the shimmering rings of Saturn, the pale, quiet tilt of Uranus, the deep blue winds of Neptune, the frozen whispers of Pluto, and the drifting snow globe calm of the Oort cloud. Together, these become a single story, a soft symphony of light and gravity. As we drift farther outward, the sun's glow fades even more, becoming a tiny spark against the backdrop of the galaxy's hundreds of billions of stars. We could keep drifting endlessly into other systems, other worlds, other mysteries. But the solar system remains with us, not as a place we left behind, but as a quiet memory that continues glowing in the distance. And so, with one last lingering look at that soft, golden spark, we release ourselves into the velvet dark, carried by curiosity, guided by starlight, and held gently by the infinite silence of space. Here, in the quiet beyond the edge of everything familiar, the journey becomes a dream, and the dream becomes a peaceful rest.